Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by the Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar lecture theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the continuation lecture of the previous one, where we discussed about coastal structures as a part of or the subset of maritime structures. This is part of the SwayamPrabha course titled Maritime Structures, Types, Construction, Pre-Service Analysis and Design, offered by the Maritime Engineering Department at IIT Gandhinagar. I am Prof. Chandrasekaran, leading this program in this institute. So welcome to the 10th lecture on coastal structures, which is a subset of maritime structures. In the last lecture, we discussed that the difference between a coastal structure and an offshore structure, what is the type of action these structures reflect when the load is applied onto them. So now we will continue to discuss some of the further types of coastal structures. Another important type of structure which is done for coastal protection is bulkhead. The term bulkhead itself refers to a massive kind of structure standing in the forefront of coastline. Bulkhead. A typical bulkhead looks like a big retaining wall but completely vertical. You may correlate this to what we call as a seawall, where the seawall has a vertical face and an inclined face. If you recollect the cross section of a seawall had a vertical surface, this is the sea side, this is the land side, constructed for a few length of meters. So, you know, this has got a vertical surface and a sloped surface, whereas bulkheads have completely vertical surface. You can see these are series of members which are purely vertical, interconnected by a deck or a diaphragm wall on the top, and they are independently or group piled at the bottom for foundation. They stand up front on the coastline to protect the coastline. So, the main purpose of these bulkheads are to prevent landslides near the shore. So, an seismic effectiveness of coastal structures constructed abutting the coast side like nuclear reactors or some of the freshwater pumping stations, etc., you need to construct bulkheads to protect them from landslides, because landslides are one of the important geotechnical failure modes that can be activated and can be devastating when a structure is constructed all along the coast side. So, landslides can be prevented by providing bulkheads as one of the protective coastal structures. These are used to protect harbors and marina areas where people used to park the small vessels and tugboats for fishing or any recreation purposes. So, the primary understanding of this kind of structure is the wave action dissipation of the structure becomes a secondary objective. The primary objective is to protect the coastline from landslides. Okay. So, bulkheads are essentially soil retaining structures and they are not wave interaction structures. Wave action is secondary, soil stability is primary. So, wherever you got weak soil or wherever you got expected liquefaction of soil happening on the coast side because of the water level arising or scouring happening, people construct bulkheads to protect the structures on the coastal side from landslide formations. The geometry of the structure looks like vertical wall, is a simple retaining wall, but pure vertical surface. It can be also constructed with series of sheet piles and soldier piles. Then they are anchored with the tie rods. A filter cloth or a drainage layer can be provided at the bottom or the toe of the wall to protect the scouring action of these bulkheads. So, bulkheads are essentially soil retaining structures. Okay. So, the structural action of the bulkheads mainly reflect the soil retaining structure. They resist lateral earth pressure and minimizes wave disturbance in harbors. They are constructed only for a short length. Bulkheads are not a longer type of coastal structures, they are only constructed wherever you got harbors. Okay. They are done at harbors, marinas and somewhere you are going mooring zones. So, bulkheads protect land locally, but disturb coastal habitat significantly. The next type of structure what we see is groins. Okay. Very interestingly friends, the which I am marking now are groins. This is a coastline, okay. This is the coastline, this is a seaside. Friends, these structures are constructed perpendicular to the coastline. Generally, you have seen bulkheads, revetments, sea walls, they are along the coastline, okay. But this is constructed perpendicular to the coastline. Possibly, I think this is one of the only structure constructed normal to the coast, into the sea, okay, into the sea. So, groins are the only maritime structures constructed perpendicular to the seashore. Most of the rest are constructed parallel. The main purpose of groins is to control the longshore sediment transport. You know what is a sediment transport? If I mark a coastline, when you have got a specific kind of coastal protection structure, maybe a seawall, okay, constructed this segment. Okay. So, when waves keep on acting towards the shore, in this portion there will be lot of sand accretion and this will get deposited on this side as sand deposition. Okay. So, now we call this process as sediment transport. So, whenever there is an intervention along the coastal structure or coastline by a coastal structure, adjacent to these two parts there will be sediment transport. To avoid this, we construct groins projecting into the sea, and these groins are generally normal to the coastal line, perpendicular, okay, they are perpendicular 90 degrees. So, groins are generally constructed to control the longshore sediment along the shore, okay, sediment along the shore is called longshore sediment. So, to control the longshore sediment transport, it helps you to reduce the beach erosion. Beach erosion is a very important phenomena which is or which cannot be actually controlled by any kind of structural formation. It is a natural phenomena, but beach erosion causes significant damage to the aesthetics of the beach and also the aquaculture growing along the beach line. Okay. So, you need to stabilize the beaches, what we call as beach nourishment. Many countries have started investing on beach nourishment. For example, in Thailand, we have got white sand beach. We have got a white sand beach in Thailand near Pattaya, very close to Bangkok. Okay. So, here the beach is protected by constructing groins. So, beach nourishment is an important aspect of attracting international tourism, and groins are structures which are also helpful in stabilizing the nourishment of beaches. The geometry looks like this. It is a rubble masonry deposit. Okay. If you look at a cross section of a groin, it looks like this. All boulder formation, big boulders and pitching. So, it is similar to a rubble masonry formation. Okay. Trapezoidal, constructed perpendicular to the coastline and getting constructed into the sea from the coastline. Okay. So, trapezoidal cross section, rubble mound construction, they are generally built in series, we call them as groin field. For example, 1, 2, 3, 4. So, these are called as groin field. Okay, constructed in series, possibly at equal intervals along the coastline. Okay. Groins are possibly the only maritime structure constructed perpendicular to the coastline, rest of them are mostly parallel to the coastline. Let us look at the structural action of groins. Groins help trap sediment on the updrift side and reduces erosion on the downstream side. Generally, on the downstream side, erosion will be very severe and significant. Groins will try to reduce the erosion on the downstream side. It is a massive gravity based rubble masonry system which has got a very low dynamic response. It's a gravity based system. Okay. Structure resists load by weight, not by geometry. Okay. This is essentially by weight. Groins solve erosion locally, but redistribute the problem regionally. That is very important. Let us say I have a coastline, okay. We construct groins. So, here we are able to solve the erosion and sediment problems, but here it will become more severe. So, it is only capable of offering a local solution, and groins of course are constructed with only rubble masonry. The cost of construction is not much, okay, and the existence of such groins will be only for about 5 to 10 years. After that they get disintegrated, you may have to reconstruct them again because of the soil erosion and because of the disintegration of bonding between the rubble stones masonry provided, etc. So, it is only a dry masonry system which gets interlocked. People put gabion boxes and you get it interlocked only with dry, fill it with clay and sand, and they gets interconnected automatically by the size of the granular arrangements and stones. So, there is no packing of cement being used here. So, therefore, they get disintegrated in due course of time and groins get completely damaged as the waves come and repeatedly attack them. So, groins are not expensive solutions, they are gravity based systems, they resist forces only by their own weight, okay. They provide solution locally, but they redistribute the problem regionally. That is a very important negative aspect we have as far as groins are concerned. Okay. The most popular and common one which is being used for coastal protection is breakwaters. Okay. One can identify the term breakwaters. It means when the waves hit the coastal line, these waves need to be broken. If we are able to break the waves as they reach the coast, they will not have energy to cause erosion. Okay. So, structures constructed to break these waves at a specific distance from the coastline based on the wave height and wave periods are called breakwaters. A typical breakwater of a rubble masonry construction type is shown here, which is built along the coast. Okay. This is the coastline, you can see this is the coastline built along the coast. Okay. This is the sand, this is the beach side and this bottom, the seaside, right. So, the purpose is to break water and reduce wave energy when they reach the shore. They are useful to protect harbors and coastlines. They reduce shoreline erosion significantly. If you look at the geometry of breakwaters, they are constructed parallel to the shoreline. The typical construction is rubble bound masonry. They are detached from the shore and sometimes they are also constructed at a submerged level. We call them as reef breakwaters. Okay. You are allowed to overtopple the breakwater. For example, if the breakwater having a trapezoidal construction is constructed, one conventional way is this is the water level. Okay, this is the land side, this is seaside. So, there is always a clear height which is available above the mean sea level, this is the mean sea level. But in other terms, you can also have a breakwater where this is possible. So, you will allow sea water to overtop. These are called submerged or reef breakwaters. The term clearly refers that I must break the energy present in wave by breaking its wave propagation energy. So, the wave amplitude will be reduced Therefore, the impulse offered by the waves on the coastal side will be reduced, and the structures constructed for this along the coastal line are called breakwaters. They are constructed parallel to the shore, they are trapezoidal in cross section, they have a massive section, the size is about, let us say, approximately about 1.5 to 2 meter, and height will be about 6 to 8 meters, and slope will be 1 in 7 to 1 in 10. Massive structures. Okay. The material used to construct them can be divided into 3 layers. One is the core layer, other is the armored layer, and then multi-layer protection. The core layer is generally sand or the quarry run material. The armor layer is a large stone or concrete units called gabion boxes, The third one is the multi-layer system where the core plus filter plus armor can be used on some. So, people use geosynthetics to provide the filter and the armored layer against erosion. Friends, metal degradation is corrosion, soil degradation is erosion. Okay. So, to prevent erosion, people use geosynthetics on breakwaters. Breakwaters actually reduce wave action in the lee side of the structure through a combined mechanism of reflection and dissipation. You can recollect reflection, absorption, dissipation. Reflection, you can say it is a sea wall, absorption, reflection. Let us put the new slide, we can write that. Reflection, you can say we have learnt it from sea walls. Absorption, okay. For the type of structure we learned for absorption, I leave it to you, please refer this, and dissipation is breakwaters. So, structural action is combination of reflection plus dissipation for breakwaters. So, how this is happening when you construct a breakwater? How does it dissipate energy? It creates calm waters by dissipating the wave energy approaching the coast. Therefore, it creates a safe mooring and cargo handling. Wherever you have got harbors or ports or jetties which are used for cargo or passenger handling, we need to construct breakwaters ahead of them to calm down the sea water, because they will then create the space for safe mooring and cargo handling. It improves the harbor entrance and maneuverability. It redirects the currents present on the water near the coastal side or the port and harbor sections, and therefore, they can create zones of controlled disturbance. Okay. So, they are primitive structures required to successful operation port and harbors. Okay. So, they are, you can say, standby structures or supportive structures to ports and harbors. Okay. It is important that breakwaters are ancillary part of port and harbor structures which are used to improve the harbor entrance maneuverability and dissipate the effect caused by the waves because of current present in the water. Okay. So, they can create something called zones of controlled disturbance. Okay. So, you will be able to handle the cargo capacity conveniently and comfortably as far as ports are concerned, if breakwaters are present. Of course, they are expensive structures, you cannot afford to build series of breakwaters. So, breakwaters reduce wave action in the lee of the structure through a combined action of reflection and dissipation of wave energy. The structural action of breakwaters goes like this: it reflects and dissipates the wave energy. Therefore, it helps us to reduce the wave height on the lee zone. It is a massive structure made of rubble bound masonry. So, it is an inertia dominant response. Therefore, the displacement or caused by breakwaters under wave loading is very insignificant, okay, very minimum. So, breakwaters play hydrodynamic role in harbors. Okay? They play hydrodynamic role or control hydrodynamic response in harbors. Reef breakwaters are special extended type of breakwaters which reduce wave energy by forcing the wave breaking, and instead of reflection they use refraction and diffraction. Okay? Submerged sills or other type of coastal structures where they are constructed near shore to interrupt the onshore sand movement and create discontinuity in beach profile. So, you can see submerged sill is a structure constructed to discontinue the coastal profile. Okay? Submerged sill will help you to nourish the sand on this side. So, you can say between the submerged sills, the band width of this will have a nourished sand. Between the submerged sills, the beach can have nourished sand. We call such beaches as terraced beach. Okay? Submerged sills are sediment control barriers, not wave breakers alone. Of course, they break the waves and control the impact caused by waves by refraction and diffraction. However, submerged sills are identified as sediment control barriers. Okay? So, reef breakwaters, submerged sills. We also have something called training walls. Training walls are structures built along the coast again using rubble masonry to improve estuarine mooring. Sometimes estuaries are created on the coastal sector where you want to move a vessel, maybe a boat or a large medium sized vessels, you need to direct the flow of water from one to another. So, you construct a barrier, okay? Construct a barrier to direct the flow of water. We call these barriers as training walls. Okay? They divert the littoral drift away from the deposition zone. Littoral drift is the sediment movement, that is called littoral drift, okay, sediment movement. They direct the sediment movement from the deposition zones from one sector to another structure. They are hydraulic control structures, not wave barriers, similar to what you have in submerged sills. Okay? They are hydraulic control structures, they are not wave breakers alone. The most popular after breakwaters in coastal system are jetties. Okay, you must have seen in many movies as well as in many real time harbors where jetties are constructed. So, jetties help stabilize the navigation channels. It reduces inlet shoaling and confine the tidal flow caused by sea. The geometry is like this: they are constructed normal to the shoreline. Okay? They are normal to the shoreline. They are long and continuous. They are usually constructed with concrete decks resting on piles. The cross section could be the land side, the sea side. These are jetties. So, you can have a nosing angle here. Then you have barriers which are kept on this as shock absorbers. Okay. The vessel can come and be parked here. Or berthing, etc. They can be moved, and you will have on the jetties, you will have cranes operating. You will have cranes operating. There will be rails on which these cranes will be moving, and they are useful for loading and unloading cargo. So, jetties are another important structures which are constructed as long continuous structures. Usually they have concrete decks resting on piles. Friends, let us try to make a comparison of different kinds of maritime structures so far what we have discussed. We have discussed sea dikes, sea walls, revetments, bulkhead, groins, breakwaters, detached breakwaters, reef breakwater, submersible, jetty, training walls. Let us compare them quickly about the geometric form, material for construction, structural action and main functions for our understanding as a summary. Okay. Sea dikes are long, massive structures. The cross section is usually trapezoidal. Okay, it is a trapezoidal cross section. Generally, people use core material as sand and clay. You can have an asphalt and grass lining stones on the top and concrete slabs as arm, support material, cover material. Sea dikes are gravity based systems. They have low permeability structure. It reduces wave run up and prevents overtopping. The main function of sea dikes are flood protection on the low lying hinterland, long term coastal defense. So, it is one of the very useful protective measure a coastline can have, which is generally practiced in India as well as in other coastline or coast rich countries like Thailand, Singapore, Indonesia. They have a lot of sea dikes constructed. Sea walls are most expensive structural system done only for short length of coastline. They are vertical. They may also have sloping walls. They are constructed parallel to the shoreline. They essentially have rubble masonry or mass concrete or asphalt. It is a rigid type structure. It reflects waves. Okay. It is vulnerable to toes covering and wave slamming. It protects roads, promenades and buildings in urban coasts which are usually constructed along the coast. One important application of seawall in the recent times is the seawall constructed abutting the nuclear reactor constructed on coastline of Japan. Revetments are sloping face following the natural shoreline. They are acting as flexible energy absorbing units. They do not reflect, they absorb, they hug the waves and absorb energy by dissipating the energy. They prevent shoreline erosion. They control with minimum reflection. The material used are stones, concrete blocks, asphalt and geotextiles. So, one can see mostly in all these kind of coastal structures, the geometric form remains massive, which is trapezoidal, and essential function is to protect the shoreline. Okay. Let us look at the bulkheads. Bulkheads are vertical retaining walls anchored to the seabed or anchored to the coastline with piles. They have steel sheet piles. They can be also constructed with concrete with tie rods. They act as soil retaining structure. Wave, action is secondary on the structures. Bulkheads are essentially soil retaining structures. They retains the land and generally used in harbors and marinas to protect the approach navigation channels coming to the harbor. Groins are structures constructed using rubble masonry perpendicular to the shoreline. Okay? They are constructed perpendicular to the shoreline, usually rubble mound construction. People also use sheet piles for constructing groins. Groins generally exist for about 5 to 7 years, then they get disintegrated because it is a rubble bound structure, the dry masonry system. It interrupts the long sediment transport along the coastline. It improves beach stabilization and controls erosion locally. Breakwaters are very commonly used coastal structures, trapezoidal in cross section, rubble mound, and they are constructed shore parallel or detached from the shore. People use quarry stones, concrete armor units to construct breakwaters. They reflect and dissipate wave energy, that is why it is called breakwaters. They break the wave amplitude and the wave energy is dissipated by abutting this kind of structure. They are essentially constructed for harbor protection and shoreline wave attenuation. Detached breakwaters are short, near shore, non-connected units. They are single units, they are not connected, they are not constructed in a continuous stretch. They are rubble mounded with low crust. Okay. They reduces wave height, helps induces tombolo formation. Okay. Tombolo formation is a very unique kind of geodetic formation or geotechnical loop being formed in the coastal line when breakwaters are constructed in the sediment transport. They are used for beach protection with controlled sediment deposition. Next comes the reef breakwater. So, another type of breakwater which is a submerged rubble mound construction. Stones and armor blocks are used for constructing reef breakwater. They help in reducing the forces by wave breaking, refraction and diffraction. It reduces wave energy before the shore, therefore, it controls erosion. Submerged sills, the term itself says it allows you to overtop. So, they are barrier near the shore, rubble bound prefabricated units, interrupts the offshore sand movement. It creates or help in creating persist beaches. So, between the segments of submerged sill, you have a nourishment of sand, can create something called a better beach. Pattaya is one classical example in Thailand near Bangkok. So, which is having submerged sills where white sand beach is being created. Jetties are most popular coastal construction which are used help navigating the channels for port and harbors. It is a long structure perpendicular to the shore extending offshore, get into the sea. It has got a concrete deck resting on piles. It confines the tidal flow, reduces shoaling effect on shores. Training walls are structures parallel to the coastline, guiding walls in estuaries. They can be either concrete or rubble bound system. It controls the sediment deposition. It improves river mouth and estuary navigation. Wherever you have got river water coming and mixing in sea, to protect the aquaculture growth and aqua life, people construct training walls. Okay. One classical example is the Chilka Lake in Odisha. So, friends, let us come to the summary of these coastal structures. No coastal structure is perfect engineering because coast is always a trade off between protection, environment and economy. Coastal engineering solutions are not universal. Every structure alters waves, current and sediments. The challenge is choosing which impact is acceptable. Please refer to this book for more details, authored by me and Jain, A.K. Jain, Ocean Structures, Construction Materials and Operation by CRC, to give you more information for interesting learning. So, friends, as a summary, in this lecture, we learnt about coastal structures, which are subset of maritime structures. We learnt about the geometry, the material, the structural action, the location and purpose, and the cost of these structures to some extent, not in numbers, but relatively with respect to offshore structures. So, friends, I think the lectures together now will help you to give a good idea about the different kinds of maritime structures deployed for oil and gas exploration, for coastal protection and other purposes. In the coming lectures, we will discuss about wave energy devices, because that is also another part of maritime structures where people construct these kind of structures for wave energy harvest and wind energy harvest. Let us see how these structures are designed and how are they constructed and how they have a geometric form, how they help us to capture the wave energy and collect and wave energy to use it for downward distribution. In the next lectures, we will discuss about them. So, friends, please go through these set of lectures clearly and put questions to yourself, learn additional reading material, refer to the SwayamPrabha website and try to answer the tutorials posted to you for your self learning and assessment. If you have any doubt, please email to us. The instructors will be available to answer your responses clearly, so that the learning exercise is reinforced, which is one of the important motive at courses what we conduct in IIT Gandhinagar. Thank you very much. Namaste.